Hello, my name is Young, and this poster is about visual working memory capacity of simple features, specifically colors. A lot of visual working memory studies use simple and abstract stimuli such as color circles or lines. However, more recent studies have shown that using more meaningful stimuli such as real-world objects can effectively boost the visual working memory capacity. But will you also remember the features of meaningful stimuli better? For example, if you just saw a puppy and now you're trying to remember the puppy, will you able to remember the colors of the puppy better compared to seeing those colors on a circle? In other words, do simple visual features that are not meaningful themselves, such as colors, also be remembered better if they are part of meaningful stimuli? To investigate this, we got a bunch of real-world objects that are not associated with a specific color and randomly colored them. And as control stimuli, we distorted these object images to get rid of any meanings while preserving the perceptual complexities. In the behavioral experiments, there were two conditions, meaningful condition and meaningless condition. In the meaningful condition, 4 of the real-world objects were presented for 1 second and participants were told to remember the colors of them. After a short delay, participants were presented one of the objects in 2 colors, and they were asked to choose which of the 2 colors they just saw. In the meaningless condition, the stimuli were replaced with the scrambled images, but everything else remained the same. Notice that in this test, participants are not asked about the identity of the stimuli, so it would be possible to do the task by only remembering the colors and locations of them. We found that even though the identities were not asked at all, participants performed better when the colors were presented as part of real objects. In experiment 2, we provided a spatial cue during the response time indicating where the target color was. So in this case, participants really could just use the spatial location strategy. Yet we still find the same pattern of data where participants remember the colors better in the real-world object condition. In experiment 3, we replaced the scrambled images with upside down images, which are very similar but hard to recognize than the upright object images. And we consistently find that people can remember the colors better when they're presented on more recognizable versions of the objects. After finding the behavioral pattern, we wanted to investigate the neural mechanism of the memory benefit. Here, we specifically investigate contralateral delay activity, or CDA, which is an ERP component found during the delay period of the working memory task that is known to index the visual working memory capacity. The task remained almost identical as the behavioral experiment, except during the encoding time, an arrow cue was presented that tells participants which side to remember. Because participants only remembered colors from one side, either left or right, we can now look at the neural activities that are contralateral to the memory side versus ipsilateral to the memory side. And once we subtract those two, we get a subtracted waveform that looks just like this. So here, the blue line here indicates the meaningful object condition, and the red line indicates a meaningless scramble condition. And as you can see, during the delay period of the task, we find larger CDA amplitude when participants are remembering colors as part of real-world objects. So in summary, we find that more meaningful stimuli can boost simple feature memory, even when clear spatial information is provided. And this is not simply due to perceptual differences between the scrambled versus realistic objects, as we replicated the same effect, but with upside down objects. The CD amplitude difference here shows that this meaningfulness benefit that we found in simple feature working memory is actually due to more active storage. And overall, we find that working memory capacity for simple features is not completely fixed. More ecologically valid contextual information can boost working memory capacity. Thank you.